Good morning, everyone. I believe everybody is still dancing in their mind from last night. Those who are not here are probably dancing in their beds, but it was a wonderful night. So thank you, Zubair and team, again, for a wonderful party. So I'm glad to see so many smiling faces at this point in time, early in the morning. My talk this morning will be a little bit off the beaten path as far as topics currently being presented at ISARC, and it has to do with smart contracts. Smart contracts are making their way quickly into the realm of project management, especially project management for challenging projects, the ones that require extraordinary skills or they are peculiar in some ways of delivery of the tasks involved in the project, but also at the same time, they may be highly risky. Those projects that require special skills are being performed in unpredictable circumstances in some ways, and they require very swift ways of achieving decision-making tasks. So supply chain management is a critical aspect of project delivery systems. And this is related to both delivery of materials as well as services on construction projects. And one of the examples of highly risky projects performed in unpredictable environments that have to be delivered practically for yesterday are projects related to disaster recovery. As we embark on inevitable climate change consequences around the world in the infrastructure that is being destroyed almost on a daily basis because of natural disasters, we can see that this need is quite dire at this point in time. So one of the technologies that underpins some of the new solutions being presented for industry use is blockchain. Is the same technology that powers cryptocurrencies. I don't expect too many cryptocurrency traders or investors in this room, although there may be some. But there are other uses of blockchain technologies that are directly related to construction. And this is actually one of them, smart contracts. So if I can get these slides to work, we can move on. I just want to give you a quick outline of what I'm going to talk about, and I know the time is limited. I want to focus on automated supply chain management and in natural disasters and potential of smart contracts in disaster recovery projects. I want to talk about current limitations in supply chain recovery in case supply chains break down, and they do often. And we're now working on a prototype of a smart contract for disaster recovery projects, which is work in progress. So I'm not ready to present a ready working prototype, but if you're patient enough and wait till next year, we'll probably have a full demonstration of the prototype. So this is a slide that shows automated supply chain management. And the chain management refers to the use of technology to automate the processes, various processes involved in the supply chain. So we have to involve ourselves in real-time data analysis and the use of analytics tools in order to come up with useful information about the data that is available. The other aspect of supply chain management using blockchain technologies is enhanced visibility of what's actually going on in the project and in the contract. We hope that this approach will result in cost savings, and cost savings are always crucial to deliver projects on budget. Most projects, if not almost all, need to be delivered within the prescribed budget for the project, although we all know that very large projects hardly ever end up within the budget that was originally prescribed. Some mega projects actually increase their initial budget limitation by an order of magnitude. And this is something that supply chain management using blockchain technology has a potential to address. So as far as technologies are concerned, blockchain is just one of them, but intelligent decision-making is also equally important. And the net result of the fusion of these two technologies will be smart supply chains, automation of the process, delivery of projects with the increased use of machine intelligence, and in some ways achieving the agility of the whole process. So natural disasters are plentiful, as I mentioned. Some of them relate to hurricanes and earthquakes, but there are also some man-made crises that are also members of the same category. So terrorist attacks, of course, all sorts of accidents that happen as a result of underperformance of human actors. But we also have, as we all know, in the recent past, epidemic breakouts. We had COVID-19. Now the world is preparing for the next big pandemic. We don't know when and where it'll strike first, but we have to come prepared. So in some ways, man-made disasters also involve technology application failures. There are some recent spectacular failures of trying to apply IT solutions, and they actually led to accidents that also sparked a number of processes that led to disasters. And then we all are facing problems related to shortage of human resources, especially resources that are highly competent in delivering projects. So all of that leads to manufacturing disruption, transportation problems, safety hazards of all sorts, and last but not least, economic loss. So all of these can be classified as disasters. So blockchain technology, of course, for those of you who are not familiar with it, is an advanced database mechanism allowing transparent information sharing within a business network. I mean, this is one of the many definitions. This is the one that we adopt for the purpose of the application of smart contracts. So smart contracts are digital forms of contracts that are deployed on blockchain, and they automatically execute agreements when certain contract terms and conditions are met. So we're not waiting for human input. Once these conditions are met, these tasks are executed automatically. So there are a number of advantages of applying this technology to smart contracts or creation of smart contracts. They're tamper-proof, at least to the point that we know right now. Nothing is completely tamper-proof, as experience shows, but they're a lot more secure than current documents and procedures being used in industry. They're traceable, so quickly we can see the chain of events that led to a particular outcome. They're trustworthy because of the numbers of checks and balances that are embedded in these smart contracts. And last but not least, they're decentralized. So a malicious attack on one particular node of the system would not necessarily break down the performance of the entire system. So in disaster recovery projects, the potential of smart contracts is indeed very significant. We have three distinct layers In smart contracts, one is the data that is related to the supply chains. Where are the capabilities of various resources that can be marshaled, commandeered to perform a certain type of contract, which has to be performed very quickly. We have various networks that can interact in the delivery of data and the transformation of the data into useful information. And then we have business layers, the various actors that collaborate on the delivery of projects with respect to that particular contract. So the smart contracts in disaster recovery projects offer the potential for increased accuracy. So collecting and verifying disaster-related information from diverse sources allows for greater trust in the accuracy of that data. So blockchain also adopts a decentralized storage mechanism, and then all transactions in the supply chains simply cannot be modified, and therefore it allows the immutability of the data and the processes that are being performed. And the security of the information being processed is also an added advantage. So algorithms that are employed to regulate data access, and they preserve user privacy, and they enhance security. There's a lot of confidential information involved in performance of contracts. Financial is just being one of them. There are aspects that are related to competitiveness of participants in these contracts, and productivity data is one of the most jealously guarded secrets among competitors, and that is usually an impediment in close collaborations on delivering these projects that are performed under duress. And added layers of security would actually enhance the ability for these highly competitive actors to play from the same sheet of music, so to speak. So there are other issues that also play a role in the delivery of projects with smart contracts. Transactions are automated, and compliance and quality assurance is also automated. One of the problems that are also being addressed by smart contracts are dispute resolution procedures. Some of the biggest problems related to contract performance, at least in the United States, but also to a large extent in Europe, is highly litigious nature of actors involved in these contracts. So in disaster recovery projects, that is simply not permissible, simply because these projects have to be delivered on very tight deadlines. So smart contracts can automatically execute predefined dispute resolution mechanisms to avoid any delay or even perceived unfairness in what's going on. This is one of the sticking points with the legal profession. Legal profession is always several steps behind the technology. So now they're voicing concerns about what if there is litigation and how the existing procurement laws and regulations of various administrative and governmental entities are going to impact the performance of these contracts with the use of blockchain technologies. So there is a lot of discussion about how quickly this technology can be accepted widely in the execution of contracts. Nevertheless, the progress is being made. Most of the barriers that exist today are not necessarily technical. They're more managerial and of legal nature. So current limitations are real as far as the implementation part of the smart contracts. There is a demonstrated limited effectiveness of backup plans for projects that have a propensity to go wrong. There is a level of difficulty in tracking supply chain recovery status. So these efforts need to be enhanced, and this is still part of the current research that goes on. And response speed to disasters is still relatively low around the world. The further away the disaster from highly populated urban centers or large distance from countries with developed economies, these are still problematic in terms of speed of how quickly they can be addressed. So what can we do as the community of practice in disaster recovery projects? We can improve cooperation efficiency among stakeholders in supply chains. There are a number of ways to address that. Smart contracts is just one of them, but it cannot act in isolation from other types of efforts. We can also enhance transparency of supply chain recovery projects, where the resources are going, what are the performance factors involved in the utilization of these resources, what are the cost factors. Every time there is a disaster and there is a lot of money changing hands, there is also a potential for corruption. So that's something that still needs to be addressed, and this is one of the human factors that are not easily addressed with any sort of technology, but there is a potential for elimination from practice of some of the most typical corruptive schemes that plague disaster recovery projects. So there is also a chance to elevate the level of automation of supply chains, and that would allow delivery of materials and services from some of the unorthodox sources. And we can actually introduce various penalty mechanisms, for example, for not sourcing out certain products and services locally. If we are concerned about, let's say, global impact of greenhouse gas emissions, for example, in a comprehensive sense. So comprehensive deployment of smart contracts can actually help in that. All right, so we have, as I mentioned, an ongoing effort to prepare the first prototype for disaster recovery projects. We're currently working on it. We have a roadmap that has been set, and some of the early decisions have been already made as far as the tools that are being employed. We're set on the use of Ethereum as a public blockchain as opposed to private blockchains, and for deployment, we're planning to use a Remix IDE. So that work is currently ongoing. We're currently undergoing testing procedures for some of the routines that are being run. So work in progress. Stay tuned. Anyone interested on that topic, I can update you in real time as our work progresses. So as far as conclusions and practical implications of this work, we already know what the benefits of the supply chain applications of blockchains will be, but there are also practical implications. We can reduce the storage burden on smart contracts as far as database is concerned. Data processing is a huge issue. Those of you who are familiar with blockchain know that this is a highly energy intense computational mechanism, and that leads to increased energy usage. So this is something that still needs to be addressed. And combined, the prototype combined with an intelligent decision center is a clear benefit that's coming up. And so one of the issues that is also stemming out of the application is all stakeholders are allowed to participate in the decision-making process. So not really picking and choosing particular stakeholders for any sort of isolated action. So this is what we're planning to do in the future, discussing optimal type of blockchain for deploying smart contract solutions. This will not be one size fit all approach. It'll be customized. So we're in discussion with various implementers as to what would suit their particular interest best. And again, it's work in progress that I'll be happy to report on